two German manufacturers have come together to ensure you have a fantastic machining process. Spindle and BLUM have been in partnership to ensure accuracy every time.
Hi, I'm Dan Hayes. We're at White House Machine Tools. So this is a spinner U5-1530, so it's one of our 5-axis machines, and it can do various different configurations. The machine with the ATC on this, it doesn't actually grow in footprint. So at the moment on this configuration we've got 54, but we can go up to a maximum of 122, but the footprint doesn't actually grow. It only grows a little bit up in the Z height. Small footprint due to the actual travelling column, and we can have 3-axis, we can have a 4th-axis or a 5-axis machine. So with this actual configuration, what we can do is we can rotate as well the B-axis and then potentially have a tailstock on the left-hand side and then do shaft work, some, say, pockets on a shaft essentially. So you don't actually have to use it as just a 5-axis or just a 3-axis. It gives you that versatility. What's clever about the U500 is the bed. So it's got a removable ring on that. If you remove the taper dowels and the cap heads, you can actually reduce the bed size to allow for smaller fixtures and a better accessibility on the parts. Various spindle options, what you can do, you can have, say, a 12K range, which gives you a bit of versatility on torque and high speed, or you can have a 20K spindle. Again, torque's very good low down, but it's obviously suitable for smaller tools, say the mould and die industry, and a 3-axis work, and then you're doing all the finishing, pencil tracing on what you'd find on a die tool. So the machine's configuration, all the mass is very low down. Again, you can have, obviously, we've got the 5-axis here, we've got the 3-axis bed on here. Now, it all builds up from the actual casting, and because the travel is on the spindle, essentially you've got that rigidity of it not actual moving. So we've always been using BLUM equipment on our machines. On this TNC7, we can access additional elements on the machine. That allows for, say, probing, but we can also check various things like runouts of the spindles. For longevity and repeatability of the components, we can dial that in. We've got a laser system on here, which is a touchless system. That's great for repeatability and the check-in, but Joe will be able to introduce his products on there.
My name's Joe. I'm from BLUM Test in the UK, and I'm their technical sales engineer. We're at White House today. We're looking at the LC50 Digilog on their spinning machine, and we also have the LC Vision integrated into the control. On the spinning machine, we're both German manufacturers, German brands, so we work quite closely with Spinner and with White House in that capacity, and we've worked with White House for many years. So at BLUM, we provide in-machine metrology, so we only work in the machine tool. So we have workpiece probes and we have tool probes as well. So tool probes can be non-contact like the laser system, they can be contact like the ZX Speeds, and then we also have a range of workpiece probes, so touch probes, scanning probes, roughness probes. So on this spinning machine we have the latest and greatest. We've got the newest kit. It's the LC50 Digilog, which has the digital function, which the traditional lasers would have, but we also have the function for analog signal. That allows us to get thousands of measurement points per second, which gives us a greater measurement of the tool. We also have our software, which is LC Vision. So it's nice having that functionality, but we need to display it somehow, and we need to give people that data, and that's where the LC Vision comes into play. Now, with this new analog function, we can give you the length, we can give you the radius. We can now measure every single flute or cutting insert on that tool. We can measure runout, we can measure thermal drift. We can now even monitor the spindle, so for your maintenance engineers, we can do really fast, quick checks of the spindle. We can do radial axial runout, we can do vibration analysis, we can do thermal measurement on the machine. So it's a real fast, quick, easy way to do checks on the machine tool, and it's all built into the machine, so it's as easy as programming a cycle, push the start button, and you've got a lot of data. Every time you take a measurement on the laser now with the LC Vision, it's logged, so length and radius, the wear measurements, everything is logged. So you can trend that tool over time and as you're machining. So there's no longer that need to guess on your tool life. There's no need to say, okay, well, I'm going to get X amount of parts out of this tool. We give you that data. We can tell you how much it's going to, how long it's going to last. But we can also tell you how it's wearing. Because we've got that visualization, we can show you how that tool is wearing as well. All of that data is exportable as well, so it's not stuck on the machine control. You can export it off, and then you can go through it and do what you need to with that data. With the new system and with the new software, we can measure a greater range of tools. So we can do taper tools, barrel tools, but we can also do form tools. So if you've got a fir tree cutter or you've got a form tool, we can actually bring that DXF file in. We can actually do a scanning strategy based around that tool. So it gives you a greater scope for measuring a wider variety of tools. So LC Vision is great. It's the visualization of your tool. So we can actually scan that tool and give you that form of that tool. So anywhere is actually visible. And we can do this thing now, which is like a best fit for your bore nose cutters. So if you're doing a lot of 5-axis work, you're not always machining on the in the Z-axis. You may have that tilted over. So we can actually best fit that for that strategy. So depending on how the tool wears and how it measures, we can actually create a best fit for that tool. We've always innovated and we've always pushed the laser system. We brought out, we called it new technology, which is where we were driving the tool into the beam and pulling it out for a measurement, which got rid of a lot of issues around coolant and swarf flying around. And as time's progressed and as technology's progressed, obviously with software and things like that, the functionality we can now get out of that laser is tenfold to what we had previously.